feed and fodder toxicities. It occurs suddenly. What happens when veterinary officers or veterinarians, they are working in the field, or even the farmers, they got the sudden onset of all these things, and at that time is how to go for the treatment, or how to save the remaining animals, or what is the exact cause. Somewhat a side kept topic. Feed, as all of we know, it is the edible substance which provide the nutrients which supports the life. And first of the most important thing is that it should be edible. And fodders, as all of you know, plant with their aerial parts are the fodders. These toxic compounds are actually? Are they, means as we can say that they are having some role, or they are really important plants? Plants should be without these toxins. But what God has given, no? God has given them the gift. As a human being or as animals, we have different protective mechanisms, or different, what you can say, a defense against each other. The wild animals, they have claw or big canine teeth. Humans, we have intelligence. So plants also, they should have some defense against the attacking enemies. For them, the attacking enemies are insects, okay, like ants, or even for them, for growing plants, you can say these herbivorous animals are also enemy. So what nature have gifted them is some compounds in them, chemical compounds like phenols, or like saponins or cyanides, to save themselves, to have a proper growth, to reproduce themselves into more plants. So all these things have been a God gifted thing to them, to have a defense against all enemies. In the evolution, we used to try untoxic or non-toxic plants for development of animal livestock as well as humans. But as the population grows, or as the stock of feeds or stock of grazing land is reducing day by day, like in India, we have only 4% of grazing land, or what we can say, there is competition from both human as well as livestock for the feeds. Like there is a competition for maize or jawar, all these things. So we have to go for some feeds which are not used routinely in the feeding of humans, or we should avoid the competition on humans. Then what happens if we are going for some unconventional feeds or some different type of feeds? Then this problem of toxicity, or then this problem of anti-nutritional factors happens. Okay, so with this background, we'll go ahead. As we can see, there are n number of toxins, and every plant contain many type of toxin. But luckily, the concentration is not that much that it cause a toxic effect on livestock, sheep, goats, as well as on the human body. If someone have to go for a presentation on toxic compounds, then it can be at least 500 slides. But what I have tried to have a common toxin from the common feed and fodder which we are using routinely in the sheep and goat feeding. So I have concised this of all PPTs around 50 slides, so that we can focus on these common toxicities. What they do, they generally affect the feed intake adversely, then feed utilization, as well as production in terms of milk or meat, and it affects the health of the animals. So these toxins or toxicities can be divided based on their chemical nature, as well as based on their nutrients they affect. These two groups we can go for this classification. So based on the chemical nature, they can be divided into some examples I have given, like some toxins are there which are proteins in nature, like protease inhibitors, hemagglutinins. Then some toxins like saponins, cyanogens, glucosinolates are glycosides in nature. Then some toxins like gossypol, tannins, they are phenols in nature, and miscellaneous antimetals or antivitamins that we will see ahead. Then next classification is how these toxins are affecting the nutrients. Their main role is they affect the nutrient intake or nutrient utilization, and they also produce some toxicities. So there are some toxins which affect the digestion and metabolic regulation of protein. They are protease inhibitors, lectins or ricin, saponins, polyphenol compounds. Then some substances interferes with the utilization or absorption of minerals like phytic acid, oxalic acid, glucosinolates, gossypols, and some substances inactivate or increase the requirement of certain vitamins like antivitamin, ADEK, then myosin, cyanogen, nitrate and nitrite. So what we will do, we will see one by one. Actually, in this classification also, some toxicities are relevant to ruminant animals. Like gossip oil, it is most linked with poultry, and even phytic acid toxicity, it is relevant with non-ruminants. So except these two, all others are relevant for ruminant animals, or particularly, or we can say sheep and goat also. So we will go with other these all toxicities one by one. Factors affecting the toxicity. So there are some factors like means age of the plant, or you can say on the class or taxonomy of the plant. So what happens? These different factors affect the toxin concentration of the plant body. So ultimately, if it will affect the animal health or animal production or the feed intake by animals depending on the concentration in the plant body. So what are these factors that we have to know, that what are that factors that affect the concentration of toxins in animal plant body? So we can see that even the slightest difference in plant may reveal the unexpected difference in the reference to hepatotoxic principles, like all of you know the Lantana camera. There are some different species. So this Lantana camera with red flower is the most toxic plant as compared to other Lantana camera. Then second is stage of growth. We can see that sorghum in case of jowar, the growing plant, or we can say the immature plant during initial stage is more toxic as compared to the mature sorghum. As well as one another example is chrysanthemum cinerepolium. Here, just before the fertilization, the flower heads, or just the flower which comes before the fertilization, at that stage of growth, this chrysanthemum cyanophlorum is more toxic than the seed bearing plant. Then next factor is parts of the plant. Parts of the plant also have toxic principle at different stages. If we see the roots or rhizomes in early spring or autumn, they have a higher toxic content. Like oat, for the example, is oat before the spring or autumn season, or you can say before the winter season, they have the highest number of toxin. Then leaves, when the photosynthetic reactions are peak, when the flowering stage is there, then leaves a higher amount of toxin. Then in case of flowers, just before pollination, they have higher content of toxin. Then in case of fruits, when they are near the ripening stage, then they have higher content of toxin. And seed, when seed contain highest number of toxin when they attain the maturity. So different parts also have different level of toxin during different stage of growth. Then soil and cultivation, as you can say that when we go for nitrogen fertilization, the toxicity or the chances of toxicity of nitrites is increasing, because this nitrogen gets converted to nitrite, that is a source of non-protein substances to the plants. So this soil and cultivation also have some effect on the toxic content of the plant. Then next is climatic conditions. For example, what we can see that the glycoside content are higher in, for example, jowar when they are rainy season as compared to dry spell. So these are the different factors which affect the toxin content of the plant. So now we will go to the different endogenous factors or toxin in feeds and fodders. So first that we will see is protease inhibitor. As the name suggests, protease is the enzyme which is helpful for the protein digestion. So in case of non-ruminants, the protein digestion start in the stomach, while in case of ruminants, although most of the protein will convert it to ammonia in the rumen, and the some amount of protein will get escape to the intestine where it will get digested. So protease inhibitor is what you can say, it is more important for non-ruminants as such. So it is mainly present in soybeans, kidney and mung beans. And in case of soybean, there are two types of protein inhibitors are present. First is unit inhibitor, which have specificity towards the enzyme trypsin, and Bowman-Burke inhibitor, which inhibits both trypsin as well as chymotrypsin enzyme. What happens whenever we feed the raw soybean, then it creates some problems. So how we can avoid it? Generally, we should not. Soybean is a very good protein source, plant protein source, because it contain the enzyme, the amino acid lysine. All almost all plant proteins are have very low amount of lysine except soybean. And for lysine, we have to depend on animal protein sources like fish meal or meat and bone meal. But soybean is the choice for plant protein, but we do not have to give it in raw form. So how we can inhibit these toxins? These toxins can cause pancreatic hyperplasia or low production. And when we give this in sheep and goat, if we will feed raw soybean, it may not have that much of toxic effect. But what happens? We will not get the good level of production, good level of improvement in the production in case of sheep and goat. So the best way is to roast, or we have to boil it. We have to feed soybean in with some boiling or with some steam treatment. So these toxins get denatured. Only one care we have to do is we do not have to boil it for more time. 10-15 minutes is sufficient for boiling, because if we are boiling it continuously for more time, some good protein also get denatured or amino acid may get lost. So first is the protease inhibitor. The main field is soybean, from where the toxicity happens. And third point is the treatment is we have to go for some roasting or steam treatment. Next is lectin, ricin or hemagglutinins. The main source is castor. Castor is found abundantly in our place at Gujarat. So what this ricin or lectins do? They bind with the mannose moiety. Mannose is the carbohydrate moiety of red blood cells and causes hemagglutination of RBCs. So it causes the inflammatory changes in the intestine, kidney as well as thyroid glands. So for lectins or ricin, mainly these are important non-ruminants, and the detoxing treatment is steam treatment. Third is saponins. So saponins, as all of you know, the lucerne, the alfalfa, as well as clover feed, they contain high amount of saponins. So saponins produce the toxicities in animals in two different ways. They causes the hemolysis of RBCs. But how they are different from ricin, or how they are different from castor? So they are different in a way that they affect the sterol component of cell membrane. In case of ricin, as we have studied, they affect the carbohydrate moiety of the RBCs. These are the problem with saponins. Saponins have another toxicity, that they can have foaming properties, or they reduces the surface tension. Let us see what is the surface tension. Any liquid, when it fall on surface, any surface, we can say this is the waxy surface of plant, or even the wooden surface. So one force is there inside this water bubble, you can say water bubble, which pull this water component to the center. So by the way, by that force or that surface tension, it maintains its shape, or it does not grow in its size. Okay, so surface tension helps for the water molecule to occupy the less or minimum volume of space. So the same thing is happening in the rumen. This surface tension helps rumen layer to occupy the minimum space, or to have some space for gas production. But what happens with the saponins? They reduces the surface tension. They reduces the power of liquid or power of rumen liquor to occupy the minimum space. So that's why what happens, rumen liquor gets spread. As well as the saponins have foaming properties. So what happens, there is increased foaming in the rumen liquor. So whenever any animal take more amount of this lucerne or other saponin content plants, then the gas which is normally thrown out of body through the process of erectation, it does not happen. It get traps in the bubbles which are produced due to saponins, and there is development of blow, that is increase in the size of the rumen. This extended rumen will put pressure on the blood vessels, and it may develop to anorexia, even death of the animal. So the saponins are responsible for hemolysis of RBC as well as the development of bloat. And as all of we know, soluble proteins also have a role for development of bloat. So in combination with soluble proteins present in lucerne, the saponins produce the bloat. So some treatment I have mentioned here, like paraffin oil, turpentine, vegetable oil, mineral oils, or even poloxamine with their dose rate. Next is these cyanogenic compound cases. From the date I have joined as assistant professor in different colleges, this is the most frequent toxicity I have come across, or farmers or even vets, they used to they used to have the experience of these cyanogen compounds. What happens? What the problem with cyanogen compounds, cyanotoxicity, is the immature stage of the jowar. Jowar is almost in all part of India. It is sold almost all part. So what happens with jowar or even Sudan grass or the plants with cyanotoxicity is that once the cut has been taken of jowar, and and that plant, the remaining portion has grown into some lesser height plant or immature plant, and if the animals or livestock are roaming like sheep, goat or cattle, they are going for grazing, and if they feed on these type of grasses, what you can say, a jowar grown after first cut, or even a planted jowar with immature stage, and when they will take a large amount of this jowar suddenly, then this type of toxicity happens. And I was going through the references, and what I saw, that this hydrocenic acid is actually volatile in nature. So it will have a sudden effect, and within 15 minutes or 30 minutes, the animal may die. Cyanogenic glycosides, they are not toxic as of them. But what happened when the plant is freezed, or it is chopped, or it is chewed, or damaged, or the plants which are found in the drought area, or the plants which are found in the flood area, the plants also contain the enzyme which activate these cyanoglycosides, or which can convert these cyanoglycosides to hydrocenic acid. So under all these conditions, the cyanoglycosides which are present in the plant get converted to hydrocenic acid, and this hydrocenic acid is responsible for all the symptoms. What it will do, it will inactivate the cytochrome oxidase enzyme. Cytochrome oxidase enzyme, as all of we know, it is essential for transfer of oxygen. So this circulating cyanide inactivates the cytochrome oxidase enzyme by binding ferric iron, which is present in this enzyme. And because of this cytochrome oxidase enzyme cannot combine with oxygen, and electron transportation becomes inhibited. Okay, so what happens, the body of animal, or even we can say sheep or goat, what they will do, they will try to remove this HCN through we can say through lung. They try to throw it out, or even in liver it get converted to thiocyanates. But when the dose is very much higher, then this cellular respiration gets hampered, and death happens due to anoxia, due to lack of oxygen. So what are the toxification symptoms are? Dyspnea, labored breathing, restlessness, tremors, convulsions. Okay, so what happens at initial point? The tissues are gets converted into bright and cherry red colored, as because there is oxygen in the blood, but the body system cannot carry that oxygen to cellular part or add to the level of cellular part. So increase in oxygen or increase in hemoglobin is there, and the mucous membranes they get converted to cherry red color. But after this stage, the stage come where the patient becomes hypoxic and the mucous membrane become the cyanotic. So whenever the farmer or vet get to such type of toxicity where there are sudden deaths within 15 minutes or 30 minutes, and death happen in a whole, you can say, whole group of animals, herd of animals, then we can suspect that it might be due to cyanide toxicity. So at laboratory levels, one method is there, that is sodium picrate test. In our college also we are doing in my department. But the problem is what happens, we use this picric acid and these are the samples. So this yellow strip is of picric acid, yellow color, and if cyanide is present, then it will get converted into brick red color strip. Okay, so this is the test. This is the qualitative test. It gives indication that it might be due to cyanide. But if we have to confirm the diagnosis, then we have to go for quantitative test. It done with calorimetric method, and generally means at our department level we do not have, but some forensic lab they have this method developed at their station. Treatment, you can go in large animals 3 gram of sodium nitrate at 15 gram, but for sheep and goat we will go for 1 gram of sodium nitrate and 2.5 gram of sodium thiosulfate in 50 ml water, and we have to give it IV. And even we can go for replacing the rumen content. In rumen, what happens, this SCN get released due to enzymes continuously. So the better way is to remove the rumen content, means if it is possible, or you can say means as fast as if we will do it, then there will be lesser chances of death. Prevention for every fodder toxicity can be done by two three things. First point I have to put forth is, if we are to allow a herd for grazing outside the home or outside the, what you can say, farm, any farm, then the right practice is to give some amount of dry roughage to the animals. What happens, as the animals are very much hungry in the morning, and we cannot, if we do not offer any feed before grazing, then they what used to do, they will go and they will eat as much of green fodder or as much of feed that is available outside. So the chances of getting the toxicity will be higher in these cases. So what in foreign countries they are trying, even we can try in our country also, that if we have to let loose the animals for grazing, then we have to feed some dry grass or dry fodder, dry roughage, even like straw, to the animals before leaving them outside the farm for grazing. Then second method is silage. Silage is a very good practice. It improves the nutrient content. It helps in the preservation of any grain fodder. And silage have one more property, that it reduces the toxic contents due to production of, during silage making, there is a production of volatile fatty acids like acetic acid, butyric acid, propanonic acid. So what happens, due to lower pH as well as due to presence of these acids, the toxin levels, different level of different toxins, it get reduced. So even we can make silage, and we can avoid this toxicity. So these things can be helpful for preventing toxicity. Then next is glucosinolate. Glucosinolate, as like protease inhibitor, is more important in case of non-ruminants. You can say what happens with glucosinolates. They are generally what happens whenever if you are feeding the kitchen waste like the cabbage or even cauliflower, and if you are feeding rapeseed or mustard seed to the animals, then this glucosinolate toxicity happens. So what they do, actually they are present in the root, stem, leaf and seed, and also have enzyme thioglucosidase with them. So this thioglucosidase convert these glucosinolates or causes breakdown of these glucosinolates into glucose as acid sulfate and thiocyanate. And these isothiocyanates are then subsequently get converted to vinyl oxazolidine VOZT, and this is the compound that is responsible for toxicity. What it do? It produces a harmful effect on thyroid gland. Thyroid gland could not uptake the iodine from the feed, so there will be increase in the size of the thyroid gland, and as all of you know, it is goiter. So glucosinolates are responsible for goiter. And what nutritionists they are doing, they are producing this rapeseed or mustard seed varieties with low glucosinolates. In market also means they are available with different trade name. If we will ask for rapeseed or mustard seed with low level of glucosinolate species or varieties, then they are available. So these all regarding the glucosinolate toxicity. Next is tannins. So what are tannins? Tannins are the polyphenolic compounds which contain sufficient hydroxyl groups, and they have nature that they get complexes with proteins and other micromolecules. Okay. So what they do, how they act as an antinutritional factor, they affect the or inhibit the activities of trypsin, chymotrypsin, amylase, lipase, and also interfere with the dietary ion absorption. So I did my master's degree on tea waste. Tea waste also have very high content of tannin, almost 4 to 5%. Tannin, it get attached with proteins. Okay, and it make protein unavailable to the rumen microbes. Second thing, what it will do, it will affect the fiber degrading bacteria as well as protein degrading bacteria. So ultimately it lowers the digestibility of food, and before doing harm in the rumen due to its astringent nature. What is astringent? Astringent compounds are those compounds which causes dryness of mouth, which reduces the salivation. So tannins also what do they do? They reduces the feed intake. And I have saw, means I have made 3 groups of animals, and I have fed animals with 10 kg, means what you can say 10%, 20% and 40% of this tea waste which contain high amount of tannin. And I have saw that the feed intake of my animals, experimental animals, was very much low in 20% and 40% tea waste feed group. Okay, up to 10% it was okay tea waste, but whenever we will increase the concentration of tea waste or any tannin compound containing compounds above 10%, then there will be toxicity symptoms like there will be decreased feed intake, there will be decreased growth rate, as well as decreased digestibility and feed efficiency. So these are some common tannin containing plants like salseed, mango seed kernel also contain tannin. As I have told, tea waste, it also contain tannin. Okay, so up till now we have seen the harmful effect of tannin, but in recent developments or in recent studies also show that if we will feed some form of tannin like condensed tannin, a particular form of tannin at lower level, it will help the animals in some regard. So that point, both the sides I will discuss. For tannin, I have already discussed that it reduces the feed intake, it reduces the protein density, it reduces the fiber density, it reduces the production. But in case of ruminants, if we will use this tannin appropriately at appropriate rate, they can be helpful also. So next slides we will study about this. There are 2 types of tannins: hydrolyzable tannins. These tannins are hydrolyzed by acids or enzymes, and they produce gallic acid and ellagic acid, while condensed tannins are resistant to hydrolysis, and they are derived from flavonols, catechins, and flavonoids. So condensed tannins. So condensed tannins, as you have seen, they are not dissolved in the rumen. Okay. So they will help for some things. Like first, when I have gone through the references, they act as an anti-bloat agents. As I have discussed already, that the fodder, the high protein fodders like leguminous fodders, they contain soluble proteins as well as saponins and causes the bloat. But when we feed proper amount of condensed tannin up to the level of 2.75 to 3 in case of goat, and even to the level of 4 to 5% in case of cattle and other ruminants. So what they do, they gets bind, they does not hydrolyze like hydrolyzable tannins. Condensed tannins remains as such in the rumen, and they gets combined with the protein, and thus they prevent the formation, they prevent the foam formation as well as gas entrapment in the rumen and the bloat. So condensed tannins at certain levels can be beneficial to the ruminants, including sheep and goat. These tannins prevents the excessive degradation of protein. So what happens in case of ruminants who are feeding protein at the end of, especially in case of goats, 16% of protein. Okay. So suppose some lactating goats are there, or by crossbreeding, if we will have some goats with very high body weight, means some is what you can say, we will have some animals with very high rate of growth. So is that 16% is sufficient? So what you can do, we can, and whatever the protein you are giving, it will get degraded in the rumen. So what you can do, we can give some type of protein which is in complex with the tannins. So this protein will escape the rumen, and this good quality protein will get absorbed in intestine without breakdown in the rumen. So that term is bypass protein, what you can say, it bypass the rumen. So this method is also used by some scientists. Many work has been done to prevent the breakdown of protein in the rumen. These condensed ions are added in the diet. So what happens? These proteins and the good quality essential amino acids which are saved from the degradation from rumen microbes, these will get absorbed at the intestinal level, and they will help and support the immune system. And many workers, they have find that if we will feed the condensed tannin, then it also have reduced the parasitic burden. Condensed tannins can be fed up to 4% level, and many studies are there, as I have shown ahead. Here these are the different level which has been given to sheep, like 3.1% or 0.5, 3%. There are the different studies which has been carried out, and what they have found, that in case of sheep, we will, if we will supply condensed tannins from chicory at the level of 3.1%, then the feed intake was increased, as well as the daily weight gain was significantly increased. So different workers like Hedon and et al. And other co-workers 2007, then as well as Romero in 2018. Okay, then this Singh and co-workers 2007, they have reported on this lobes, they have reported that the both feed intake as well as the weight gain was increased on feeding of condensed tannins through different plant sources. Also, some studies were there by infecting the goats or sheep. So what scientists they have done, they have infected sheep or goats with these different parasites. Okay, and then they have provided condensed tannins at the level of 2.1 through tree leaves or through some plants. Okay, so what they have find, like different scientists, they have found that there was a decrease in fecal egg count, worm burden, worm fecundity. Okay, so many they are report, like Iqbal and co-workers on 7, then this Joshi and co-workers on 11. So many studies have supported the finding that condensed tannins are beneficial in some way if we give them at lower rate. After finishing the tannins, we will go to the next antioxidant factor, that is antivitamins. Okay, so this is the table I have prepared from references. where I have seen that some feeds like soybean and kidney beans, they contain the anti factor like lipoxygenase. It oxidizes and destroys the carotene vitamin. It is a precursor of vitamin A. Then it destroys the vitamin E. Then some anti factor are present in sweet chlore like dipomerol. They reduces the prothrombin level in blood and prevents blood clotting. Then the anti factor like linatin, which is present in the linseed, it destroys the pyridoxine vitamin. Then niacin anti is there is in maize and wheat bran. It acts as anti-niacin compound. Then anti-thiamine compound, it is present in bracken fern. It destroys the thiamine. Okay. So these are some anti-vitamin additional factors that were discussed. Then next is nitrate and nitrate poisoning. So as I have discussed earlier in this slide only, actually this nitrate and nitrite are NPN compounds. NPN means non-protein nitrogenous compound. So what happens in case of ruminant animals? They have a special system as a rumen, where what happens if we will feed animals with proteins, pure proteins. Pure protein means the proteins are made up of, as all of you know, peptide bond. Okay, so their proteins will get degraded in the rumen to ammonia, and this ammonia will be used by bacteria for producing their own body protein. And how this bacterial protein or microbial protein is get by animals? These microbes, different microbes, even fungi, bacteria, all they are generally get washed out from rumen reticulum to abomasum and even to intestine. And when these microbes are gets digested, animal gets the microbial protein. And other way is the protein which is not dissolved or which is not utilized by microbes will get escape to the intestine and it will be utilized by ruminants. So two ways are there to get the protein for ruminant animals like sheep and goat. And even if we will give non-protein substances like this nitrate or nitrite at particular level, okay. So non-protein sources are those sources like urea also, which are not protein nature. They do not contain any peptide bond. But what happens whenever they will get entering in the rumen, they will get converted into ammonia. And this ammonia will be utilized by the rumen bacteria for producing their own body protein. And this bacteria, when they will get washed out to abomasum and intestine, that protein will be available to the animal. Okay. So these nitrites are NPN compounds like urea. At certain level, they will not cause any toxicity, or even they will help for production of protein by for ruminant animals. But what happens during the periods like drought? The amount of nitrate in the soil get increased. As there is lack of bleaching, there is no water supply, then there is reduced nitrate uptake. As water is not there, so plant cannot take the nitrate, as well as decomposition of organic matter. And when we apply higher amount of N containing fertilizers, then also the nitrate content of plant get increased. And when animals consume such plants, especially during the winter season, after means applying of water to the plants, then the nitrate content of plants get increased, and this toxicity happens. What happens actually? In case of ruminants, the nitrate from feed get converted to nitrite, and as all of we know, it will get converted to ammonia. This process I have already explained to all of you and to the microbial protein. But when the nitrate content is too much or nitrate content is too much, then what happens? This nitrites get absorbed in the blood, and in bloodstream this nitrate get combined with the hemoglobin molecule which carries the oxygen and converts this hemoglobin molecule to methemoglobin. Okay, so problem with methemoglobin is it carries oxygen but not at the same level like that of hemoglobin. I think it carries almost 4 molecules of oxygen. So what happens The nitrate get converted to nitrite, and this nitrite get bind with hemoglobin. This continuous process gets going on, and at one time almost 50-60% of hemoglobin in the blood gets replaced by methemoglobin. Okay, and some ions can tolerate up to 50%, but once it cross 70-80% level, then there will be toxicity of nitrate. Okay, the nitrate content plant are generally oat or even jowar. These are the examples. So what happens in nitrate poisoning? There will be rapid, noisy, and difficult breathing. Then blue chocolate colored mucous membranes, dark chocolate colored blood. There will be abortions. There will be weakness, coma, convulsions, and death. So these are the signs of nitrite poisoning. So in case of nitrate poisoning, we can give the IV injections of methylene blue. So this methylene blue helps for conversion of met hemoglobin to hemoglobin. Okay. So this thing happens due to nitrate toxicity, and as I have told that we have to feed the stock with some dry hay or dry fodder before allowing them to grazing. Then after fertilization, we have to limit the rate, as till now in India, what they are doing, they will purchase this urea fertilizer, nitrogen fertilizer, you can say, and they used to apply to the soil or you can say land, and they will not put any phosphorus or even potassium fertilizer. So there is specific ratio for application of fertilizer. I think the ratio is 6:3:1. So if they are applying only urea, then there will be increased content of nitrite, and if this nitrite will get absorbed by the plants like jowar or even oat, then there will be toxicity. So we have to go for proper fertilization. Then next is oxalate poisoning, oxalate. Okay, so what this oxalate do? It is present in sugarcane. In our area in Maharashtra, from the native of Kolhapur. So it is a sugarcane blade inbuilt. Even UP, the sugarcane, there is high production of sugarcane. Tamil Nadu also. So what happens as this plant grows? Means farmers, livestock owners, they used to cut the leaves and they will feed to the animals, even sheep and goat. So what happens? They have high amount of oxalate contained in it. What oxalate do? Oxalate generally gets bind with calcium as well as magnesium. And what happens? There will be low amount of calcium. And as a veterinarian, all of you know that what body do? Calcium and phosphorus ratio in bone is 2:1. And even in blood also, body tries to maintain this ratio. Okay. So as there is lower amount of calcium will get absorbed due to oxalate, because whatever the calcium is there in the feed, that will get bind with oxide of sugarcane, and even it is present in higher amount in paddy straw also. So if we will feed higher amount of straw as well as sugar tops or as a only source of feed to the sheep and goat, then what will happen? It will get bind with the calcium. The ratio of 2:1 get disturbed. So what body will do? It will try to mobilize the calcium available in the body. So where calcium gets deposited in the body? Bones. So it will mobilize the calcium from the bones. So there will be demyelination of bones. Bones will get softened. Okay. It causes bigger disease in horse. That is a different thing, but it will also causes some bone disorders in case of cattle as well as sheep and goat. So oxalate toxicity happens this way. Also, what happens in case of chronic oxalate toxicity, if the dose rate is not that much high to have an acute toxicity, there will be formation of uroliths. Okay, this calcium, this oxalate will help in the formation of stone in the kidney or needles in the kidney. Okay, so these are the problems of oxalate poisoning. So what happens in acute oxalate poisoning? It causes a sudden decrease in the serum calcium, which impairs the normal cell function and causes animals to develop muscle tremors, weakness, and it will lead to collapse and eventual death. While in case of chronic oxalate toxicity, there will be kidney failure. So these are some critical levels which are given by different scientists. For cattle, they have reported from 2 to even 7% of oxalic acid, while one report is for goat also. So they have report around 2.6 to 2.75%. So our stock contains around, you can say, 1.5%. Another thing I want to say it clearly, that almost every feed it contains some different type of toxin at some different level. So if I am sowing toxins from maize or from soybean or from straw, it does not mean that we should stop all this feeding to the animals. We have to do, but we have to make some in combination feeding. We do not have to feed the animals with, for example, whole day with sugarcane top only. We will not give concentrated mixture. We will not give dry roughage as it is available in bulk at the time of cutting of sugarcane. So we will feed only animals with that. We have to avoid. We have to avoid the overdose of toxin or overdose of any single plant to the animals. So these are the symptoms of oxide poisoning, like severe inappetence, straining, constipation, dryness of muscle, increased blood water time, dyspnea. These different symptoms are seen. While in case of sheep, symptoms were weakness, incoordination, tetany. These have been reported for by the different workers. What we can do means, if farmers don't have the choice except these straws or even the sugarcane tops, they have to feed them. Then we can go for supplementation of dicalcium phosphate. We can give more amount of dicalcium phosphate. Even in literature, when I have gone through literature, I have seen the lime treatment. Lime, चूना जो होता है अपना, that lime treatment also can be done to the chopped sugarcane tops, you can say, or sugarcane leaves. So what we are doing, if oxide gets bind with calcium, we are supplying some extra amount of calcium to the animal, either through dicalcium phosphate or through this lime treatment. Okay, so these are some preventive measures for oxide toxicity. Then next, as all of you know, subabul. Subabul, it's a plant belongs to genus Lucana, and it is a very good fodder. Around 18% of CP is there. So, but what happens? It also have one toxin, that is mymocin. So what this mymocin do? Mymocin do? It gets extensively degraded to dihydroxypyridine (DHP) in the rumen, and when this DHP gets absorbed in the bloodstream, it reaches the thyroid gland and it inhibits the biosynthesis of hormone thyroxine. Enzymes which are required for thyroxine hormone synthesis are enzyme system which gets blocked by this DHP, dihydroxypyridine. So the safe level is 0.14. So as this is a very nutritious fodder, so many studies they have been conducted in foreign as well as in our country also during 1990, 2000, recently also. So what the scientists they have found that if we will replace this the total dry matter by 25 to 50% by subabul, and the CP content of constant mixture even up to 50%, then these are not toxic in case of all animals, the dairy animals as well as meat animals. In sheep and goat also they have found. Then what we have to do? We have to feed the subabul. If the dry matter intake in case of sheep and goat is, it is around 3 to 4% of body weight. Okay, so for Mehsana goat, as we are going to hear the trial, here we seen the diameter, total diameter intake was around 1 kg for Mehsana goat. So we can give up to 250 gram of this subabul or even 500 gram of subabul. So this way you can take care of this myosin toxicity by subabul. And one interesting thing has been also studied by scientists, that some rumen microbes in Hawaii and Indonesia, they are capable of detoxifying the myosin. The microbe they have found is synergistic zoonci. So the Hawaiian goat, they do not produce any myosin toxicity because the synergistic zoonci, it causes breakdown of myosin in the rumen and prevents the toxicity. So means research they are going on in even what scientists they have tried that they try to transfer these rumen microbes to the other animals from different countries. So that also we can do. Also we can as in case of oxide we have supplied the calcium, and here the effect is on thyroid gland, so we can supply ferrous sulfate. Also, sun of leaf meal can be carried out. So this thing we can do in case of myosin toxicity. Scientists they are working, people they are working for finding some unconventional resources, and the typical character of unconventional feeds or unconventional resources for animals is they contain the toxin. So I have worked on tea waste in the masters. I have continued the same unconventional feeding area in my PhD also. So I was lucky to work on the Jatropha carcass. Jatropha, as all of you know, it is a biofuel. It is used for biofuel, and even our government policy is there to replace the petrol or diesel with some biofuels. Even electric cars they are trying. So at that time, that's why we have selected this topic. And what I have done, I have collected Jatropha seeds. They are very toxic due to forbol ester toxin. And the typical symptoms of this probiotics is that they will cause severe diarrhea, bloody diarrhea in animals. And there are many cases from Africa, even in India also. Some news were there that the children they have taken this, they have eaten these seeds of Jatropha, and they have got this bloody diarrhea and they died like that. So that was tough challenge for me during PhD to detoxify it. So I have tried many methods like treatment with alkali or even acid, ethanol, methanol extraction. One treatment was successful as it was patented. That treatment was patented. So I could not disclose the name of the treatment. But what happened one day, I was working with that treatment in the laboratory. I'm just sharing my experience as a researcher. And there were two bags, one with raw Jatropha meal. Meal is removing the oil from Jatropha, and that meal we were using for animal feeding. So I have detoxified it with specific treatment, and I have kept that in plastic bag, treated Jatropha meal and the raw Jatropha meal. And means in hurry or some way, I have forgotten to keep that in steel almirah. So next day when I came back to the laboratory, I saw that one bag was the Jatropha in one bag was missing, and another bag was totally safe. So I was thinking and searching. Then I saw some marks of these rats. So rat has eaten that treated or detoxified Jatropha. I thought that means my method is right. Okay. So what I have done then, I have gone for specific rat experiment only. So I have taken some 40 to 48 rats and make 3-4 groups and fed this Jatropha at some different level to different rats. Fed some raw Jatropha also and this treated Jatropha also, Jatropha. But what happened after 3-4 days of feeding, there was a redness, red mark in my that litter, rat litter. So I thought my experiment has been almost, it is unsuccessful. How it is happened that red marks mean it is blood diarrhea. So I was in tension. Then I have talked with my guide sir. Then I have gone to pathology department of IVRI and tested that thing. So what I have seen in raw Jatropha fed rats, there was RBCs. But in case of this treated, there was no RBCs or there was no blood. Then how it has color the change? How the color of litter has changed? I was confused. Then somewhere I got the point that in my childhood days, one Jadugar they used to come in our school or on the streets also. They used to cut this lemon by one knife, and the blood will come from that lemon. So I have inquired to that this bran supplier, that litter supplier. It was actually a bran only, the outer covering of rice. So somewhere that litter material was in contact with and how it has happened? It was in contact with the turmeric. The Jadugar, what he was doing, magician, in my childhood days, that he was means dipping the knife in the haldi, and then he used to cut that lemon, and he will show the lemon juice as blood to us. Same thing has happened with the rat, and luckily it was not the blood. So that experiment was successful. Then I have gone to experiment with the lambs, with large animals, because I have to prove that in rat it was non-toxic, but for large animals, is it toxic or non-toxic? So there also what happened, after 3, 4, 5 days, the diarrhea has happened in the lambs, which has been supplied with this Jatropha meal, which is detoxified. The toxin has been removed by me. So again, I have to go for some searching, soul searching, then composition. I have gone for the protein composition of the feed. There, what I have saw that the acid insoluble ash content of that feed was almost 50%. What happened? The company, I will not take the name of company or the supplier. So what he has done, he has to supply us some bulk amount of Jatropha, this detoxified Jatropha meal. So he has mixed that meal with sand, white sand. And as all of we know, though, if we will feed animals with or this sheep with 15-20% of sand, there will be diarrhea. So again, I have marked that it is due to the sand. We have talked with him. We have again tested some good quality feed, so it was successful afterwards. So these things, detoxification, the toxins, detoxification, toxicity, these are the part of animal nutritionist and even our veterinarians. So that is all for the today. I think I have almost finished my PPT. So thank you all.